In 2012, a machine built in the 1970s, older than the internet, older than most of the people watching this, crossed a boundary that no human-made object had ever crossed before. And the moment it did, it sent back a reading that should never have been possible. Not just a reading that was unusual, but one that, according to every equation we had, was outright impossible. And here's the part nobody tells you. NASA's own scientists looked at that data, and for a while, they refused to believe what their own spacecraft was showing them. What Voyager 1 found at the edge of the solar system didn't just surprise physicists. It broke the map. Stay with me, because by the end of this, the impossible thing won't be what Voyager found. It'll be something much closer to you than the edge of the solar system. Let's be precise about what we're talking about, because the scale of this is almost impossible to hold in your head. Liftoff. Voyager 1 launched in September 1977. Its mission was only meant to last a few years, a brief tour of Jupiter and Saturn, a few photographs, and then silence. Instead, it just kept going for nearly half a century. It is now the most distant object human beings have ever made, over 16 billion miles away. So far, in fact, that a radio signal traveling at the speed of light takes almost an entire day to reach it. Think about that. You send a command in the morning, and the answer comes back 2 days later. For decades, Voyager flew through the Heliosphere, a vast bubble blown by the sun, a cocoon of solar wind and magnetic field that surrounds everything you've ever known. Every planet, every person who has ever lived, all of it inside a single bubble. And physicists had a theory about what would happen when Voyager finally reached the edge of that bubble, the boundary known as the heliopause, where the sun's influence ends and true interstellar space begins. They had the equations, they had the models, and they thought they knew what to expect. They were wrong about almost all of it. And the first thing that broke was the one thing everyone had been certain about. Here's what everyone knew was going to happen. Space is empty. Everyone knows that. The farther you get from the sun, the emptier it gets. The solar wind thins out, the particles spread apart, and beyond the edge of the solar system lies the interstellar void, the emptiest, loneliest nothing imaginable. So, when Voyager crossed the heliopause, the prediction was simple. The density of particles around the spacecraft should remain incredibly low. Interstellar space is empty. That's the whole idea. Then, in 2012, Voyager crossed that line, and its instruments measured the density of plasma around it. It didn't drop. It jumped. Not by a little. The plasma density around Voyager rose by roughly a factor of 20 to 50. The spacecraft had left the sun's bubble, and the empty void of interstellar space turned out to be denser than the outer edge of the solar system had just left. Let me tell you why that seems impossible, and then why it actually makes sense. The answer is more beautiful than the mystery itself. Inside the heliosphere, the sun is doing something violent. It's constantly blowing a wind of charged particles outward in every direction, a gale of plasma rushing out at hundreds of kilometers per second. And that wind does something you might never guess. It pushes interstellar material away. It carves out a cavity. It sweeps the neighborhood clean. So, the region just inside that edge isn't empty because space is empty. It's empty because the sun is actively bulldozing it clear. Cross that boundary. Step beyond the reach of that solar bulldozer, and you find what was there all along. The true interstellar medium, which is quietly denser than the artificial emptiness the sun had been maintaining for billions of years. Sit with that for a second. The emptiness of our solar system isn't natural. It's manufactured. You've spent your entire life inside a bubble that the sun scrubs clean around you, second after second, without ever knowing it. And the wall of that bubble is 16 billion miles away. So, the first impossible reading wasn't impossible after all. It was a clue. It told us the edge of the solar system isn't really an edge. It's a shoreline. And on the other side of that shoreline, the ocean was doing something that made NASA's scientists question whether Voyager had even crossed at all. Because there was a second reading. And this one wasn't so easy to explain away. Before we get to the reading that sparked a debate inside NASA, there's something about that boundary you need to understand. It sounds like science fiction, but it's entirely real. At the edge of the heliosphere, there's a wall of fire. I mean that almost literally. The plasma in that boundary region reaches temperatures of tens of thousands of degrees. We're talking around 30,000 to 50,000 degrees. That's hotter than the surface of the sun. It's a wall of superheated matter wrapping around the entire solar system. And Voyager flew straight through it. It didn't melt. It didn't even notice. Now, how can a spacecraft pass through 50,000 degrees and survive? This is where most people's intuition about physics falls apart, and where a physicist knows better. There's a difference between temperature and heat. Temperature measures how fast individual particles are moving. Heat, on the other hand, is how much energy actually transfers to an object, and that depends on how many particles there are to transfer it. Out there, the particles are moving incredibly fast, which gives that enormous temperature. But they're also so unbelievably sparse, just a handful of particles per cubic centimeter, that there's almost nothing there to pass that energy onto Voyager. A few blisteringly hot particles strike the spacecraft every so often, but there simply aren't enough of them to warm it up. It's the difference between a spark and a bonfire. A single spark can be thousands of degrees, but it lands on your skin and does nothing because it's just one tiny thing. Now, imagine a spark so lonely that there might be only one of them in an entire cubic mile. That's the wall of fire at the edge of the solar system. Incredibly high temperature, almost no heat at all. So, Voyager sailed through a 50,000-degree wall as if it were a cool evening. Another impossible thing that turned out to be true once you understood how it worked. Two anomalies down, both explained. And maybe you're thinking, okay, so the impossible things always have an explanation. The strange readings always work themselves out. That's where this stops being true, because the next reading has never been fully explained. And it's the one that made serious scientists wonder whether everything we just concluded might be wrong. To understand why this reading shook people, you need to know what the magnetic field was doing out there. The sun has a magnetic field, and it fills the entire heliosphere, pointing in a certain direction and spiraling outward as the sun rotates. Interstellar space also has a magnetic field, the galaxy's own field, woven through the space between the stars. And importantly, that galactic field points in a different direction than the sun's field. So, physicists had a clean, elegant, and obvious prediction. When Voyager crossed the heliopause, when it left the sun's magnetic domain and entered the galaxies, the direction of the magnetic field it measured should swing, rotate, and change. That shift in direction would be the definitive proof that it had left the sun behind and entered interstellar space. Voyager crossed. Everyone watched the magnetic field. It didn't turn. The direction of the field barely changed at all. It stayed almost exactly aligned with the sun's field, the very field of the region Voyager was supposedly leaving. This wasn't a small problem. It was the kind of problem that sparked arguments between people who had devoted their lives to this mission. Because if the magnetic field didn't turn, then by the textbook definition, maybe Voyager hadn't crossed the heliopause after all. Maybe it still wasn't in interstellar space. Some respected scientists argued exactly that the 2012 crossing wasn't the true boundary, and that the real heliopause lay farther out still. The density reading said, "You've crossed." The cosmic ray reading said, "You've crossed." The magnetic field reading said, "You haven't gone anywhere." The spacecraft was giving contradictory answers about where it was. And here's the honest truth. The one any real physicist has to admit, we're still not entirely sure why. The leading idea is that the galaxy's magnetic field gets draped and combed into alignment with the sun's field right at that boundary. That the two fields link up there and run nearly parallel across the transition zone. So the sharp turn we expected gets smoothed out. It's a solid idea. It may well be correct. But the models that were meant to predict this boundary never predicted this outcome. And this region is strange enough that physicists openly admit we need new models to fully describe it. So, here's the tally at the edge of the solar system. A void that turned out dense in the region it was supposed to be emptier than, a wall of fire that didn't burn, and a magnetic field that refused to behave as predicted. 3 predictions, 3 surprises. And then Voyager heard something. In the supposed silence of interstellar space, there was a sound. We're told space is silent. In the everyday sense, that's true. There's no air to carry sound the way it reaches your ears right now. But Voyager doesn't have ears. It has a plasma wave instrument, an antenna designed to listen for vibrations in charged particles, the ripples that move through plasma the way waves move through water. For years, that instrument mostly picked up events. Every so often, the sun would unleash a violent burst, a coronal mass ejection, and about 13 months later, that shock wave would reach Voyager 16 billion miles away, setting the interstellar plasma ringing like a struck bell, loud, dramatic, then silence again, until scientists took a closer look at the quiet stretches between those bursts. And in that supposed silence, they found something they hadn't expected. A hum, a faint, steady, narrow tone, a persistent drone coming from the interstellar plasma, humming on and on between the solar storms. Not triggered by the sun, not a one-time event, just a background sound of interstellar space itself. The interstellar medium, it turned out, is never truly silent. It has a voice, and it never stops speaking. I want you to feel just how strange that is. There's a region beyond everything you know, a place no human will visit in any of our lifetimes. And it isn't the cold, dead silence we imagined. It's faintly, constantly singing. The only reason we know that is because a 1970s machine, running on the last flickers of a plutonium battery, was still listening. So, that's 4 impossible things. And every one of them turned out to be real. You might think that's the story. Space is stranger than we thought. Roll the credits. But I promise you at the start that the truly impossible thing wasn't what Voyager found out there. It's something much closer to you. And now I can tell you what it is. Because the real mystery isn't in the data. It's in the fact that we predicted any of it at all. Step back and look at what actually happened here. A species of primate, living on the surface of one small planet orbiting one ordinary star and one arm of one galaxy among hundreds of billions. This species scratched a few symbols onto paper, equations, and using nothing but those symbols, it predicted the density of plasma, the behavior of magnetic fields, and the temperature of a wall of fire in a place 16 billion miles away that not a single one of its members would ever see. And it was mostly right. Think about how astonishing that is. The universe was under no obligation to be understandable. There is no law that says reality must be describable by mathematics that can fit inside a human skull. And yet, time and time again, we write down an equation here on Earth, and the cosmos, billions of miles away, obeys it. Even our failures prove the point. When Voyager's readings came back as impossible, what did that really mean? It meant reality disagreed with our equations. But we were so convinced the universe is lawful, so convinced it is fundamentally intelligible, that we didn't conclude the universe was random. We concluded our equations weren't good enough yet. We assumed there was a deeper law we hadn't found, and we went looking for it. The physicist Eugene Wigner wrote a famous essay about this. He called it the unreasonable effectiveness of mathematics in the natural sciences. His point was almost a confession. There is no good reason mathematics should work as well as it does. It just does. He called it a miracle, a word a Nobel laureate doesn't use lightly, and said it was a gift we neither understand nor deserve. Einstein put it even more bluntly. He said the most incomprehensible thing about the universe is that it is comprehensible. The eternal mystery of the world, he wrote, is that we can understand it at all. So, here is an impossible thing I promise you. It was never the density or the fire or the field or the hum. The impossible thing is that a piece of the universe, you, made of the very same atoms as that interstellar plasma, can sit here and understand the rest of it, that the cosmos gave rise to something capable of reading its own laws. And once you truly feel the weight of that, you're standing exactly where the deepest questions in human thought have always begun. Not what is out there, but why is any of it knowable? Why is there order instead of chaos? Why is there something rather than nothing at all? Voyager flew to the edge of the solar system to answer a physics question. What it actually did was bring us to the doorstep of a much older one. Here's what makes those questions so hard to walk away from. The order Voyager found isn't vague, it's precise. The universe runs on a small set of fundamental numbers. The strength of gravity, the strengths of the forces that hold atoms together, and the energies woven into space itself. And physicists have noticed something that genuinely unsettles them. Those numbers appear to be balanced on a knife's edge. Nudge just a few of them by a tiny fraction of a percent, and you don't get a slightly different universe. You get no universe worth speaking of, no stars, no chemistry, no structure, nothing that could ever build a Voyager or a scientist to launch it. The cosmos seems tuned, with eerie precision, for the possibility of complexity. For many thinkers throughout history, that has pointed to something. If the universe is intelligible, law-governed, and finely balanced toward order, that looks less like an accident and more like something authored. This is the intuition behind one of philosophy's oldest arguments, the argument from a first cause. Every effect we know has a cause. The chain of causes cannot hang on nothing. So, there must be something that grounds it all, something that is itself just another effect, a first cause, a reason the universe is lawful rather than lawless, ordered rather than empty. But intellectual honesty requires telling you the other side, and it's a strong one. Many physicists answer the fine-tuning puzzle without calling on any author at all. Maybe there isn't just one universe. Maybe there are countless universes, with their constant set to every possible value. And, naturally, we find ourselves in one of the rare few that allow observers, because we couldn't exist in any of the others. That's the multiverse, paired with the anthropic principle. And to the first cause argument, the sharpest counter is a question in return. If everything needs a cause, then what caused the first cause? And if something can exist without a cause, why not the universe itself? I'm not going to give you a neat, tidy answer, because there isn't one. Anyone who claims otherwise is selling you something. What I can tell you is that the question is real. It's not a gap in our knowledge that better instruments will simply close. Voyager carried the finest instruments we've ever sent that far, and all they did was make that question louder. So, what did Voyager 1 find at the edge of the solar system that was physically impossible? By our old models, a void that was denser than the solar system it had just left, a wall of fire that gave off no heat, a magnetic field that refused to turn, and a silence that turned out to be singing. But those weren't the impossible thing. They were breadcrumbs. Each one was reality quietly telling us, your map is incomplete. And each time we didn't abandon the map. We assumed the universe was lawful and went searching for a deeper law. Because everything we've ever learned has shown us the cosmos isn't random. It's ordered. It's knowable. And nobody can tell us why it had to be that way. That's the impossible thing. Not 16 billion miles away. Right behind your eyes. A universe that made something capable of understanding it. If that sits with you the way it sits with me, then you already belong here. Because this is exactly the question this channel exists to sit inside. Subscribe and stay in the discomfort with me. Next time, we go even deeper. The map is incomplete. Let's keep walking off the edge of it together.